Good morning. Today's topic is variation of conductance with concentration. Okay, conductivity changes with concentration of electrolyte. Okay, conductivity changes with concentration of electrolyte. Okay, concentration of electrolyte. Now, what happens to conductivity? Conductivity decreases as concentration decreases because number of ions per unit volume decreases. So, concentration decreases, number of ions per unit volume decreases. So, conductivity also decreases. Okay. Conductivity decreases as concentration decreases because number of ions per unit volume decreases. Okay. Now, on dilution what happens? On dilution, concentration decreases. That is, number of ions per unit volume decreases. So, actually conductivity on dilution, concentration decreases, so conductivity decreases. Now, we know G is equal to kappa A by L, where G is the conductivity, kappa is the specific conductance, area of cross section, and L is length of the electrodes. Okay. Now, the distance between the two electrodes, length L. Okay. Now, also we know lambda m, molar conductivity. Lambda m is molar conductivity equal kappa A by L. This is in the case of electrolytic solution. So, lambda m is equal to specific conductance into volume of 1 molar electrolytic solution. So, lambda m depends upon the volume of the electrolytic solution, where L is unity and A will be equal to volume of the electrolytic solution. So, on dilution, as the volume increases, lambda m increases. What happens if dilution happens? On dilution, what happens to the electrolytic solution? Volume V of electrolytic solution increases. So, what happens to molar conductance? So, lambda m increases on dilution. Okay. So, as concentration decreases, dilution means concentration decreases. As concentration decreases, lambda m increases. Okay. This is in the case of molar conductivity. Okay. We can also draw graph lambda m against concentration. Okay. Now, the variation of lambda m with concentration is different for strong and weak electrolytes. That is, graph will be different. Okay. Graph will be different for strong and weak electrolytes, because in the case of strong electrolytes complete dissociation is taking place, but in the case of the degree of dissociation of weak electrolytes is less. So, the graph will be different. Okay. That is, the variation of lambda m with concentration is different for strong and weak electrolytes. Okay. As the concentration approaches zero, lambda m will be lambda 0 m, that is, which is called as the limiting molar conductivity. Okay. Now, let us discuss the variation of lambda m with concentration in the case of strong electrolytes and weak electrolytes. Okay. In the case of strong electrolyte, example HCl, NaOH, etc. Okay. There is a relation between lambda m and lambda 0 Fm, that is lambda m will be equal to lambda 0 m minus a c raised to 1 by 2, that is root c, where a is the constant. A is the constant. Now, in this case, there is complete ionization. Ionization of ions in the solution is taking place. Okay, in the case of strong electrolyte, complete ionization taking place. So, the complete ionization concentration of ions in the solution is proportional to the concentration of strong electrolyte. Okay, so due to complete ionization, concentration of ions in the solution, is proportional to the concentration of strong electrolyte. Proportional to the concentration of strong electrolyte. Okay. Because complete ionization is taking place, so concentration of ions in the solution is proportional to the concentration of the strong electrolyte added. We are adding the strong electrolyte to the solution. So, concentration of strong electrolyte added. So, we are drawing a graph lambda m versus root c. Here, the slope will be minus a. Minus a will be the slope of this graph. Okay. Now, the graph will be like this. Okay. Lambda m versus root c. The graph will be like this. Okay. Graph will be like this. So, as the concentration decreases, lambda m increases. And if we extrapolate the graph, we will get the concentration reaches 0. So, we will get lambda 0 of m. This is the graph in the case of strong electrolytes. And A, the slope A depends upon nature of solvent. A depends on nature of the solvent. Then it also depends upon type of electrolyte we are using. Different electrolytes, strong electrolytes are different types, HCl, NaOH, etc. Type of electrolyte also depends upon temperature. And extrapolating, we will get the value of lambda 0. Lambda 0 of m can be found. Okay. Next, in the case of weak electrolytes, the dissociation is different. Okay. The ions, the electrolytes will not be dissociate completely. Okay. So, in such a case, what happens? The graph will be different. So, weak electrolyte. Examples: acetic acid, ammonium hydroxide, etc. In this case, the degree of dissociation is less. Not complete ionization will not take place in the case of weak electrolytes. And alpha is the degree of dissociation, which will be equal to lambda m by lambda 0 of m. Lambda 0 of m is the limiting molar conductivity. Okay, and the graph will be like this: lambda m root c. Okay, so this will be the graph. At lower concentration, lambda m increases. Okay. This will be the graph. Okay. Now, what happens with increase in dilution? Increase in dilution. Concentration concentration decreases. As dilution increases, concentration decreases. Okay, so degree of dissociation increases. As the concentration decreases means degree of dissociation increases. Okay, degree of dissociation increases. Degree of dissociation increases. As the degree of dissociation increases, conductivity increases. Conductivity increases. Okay. So, as dilution increases, concentration decreases. As dilution increases, what happens? Conductivity increases. So, at higher concentration, conductivity is less. Okay. As the concentration decreases, on dilution concentration decreases and lambda m conductivity increases rapidly. At lower concentration, there is a steep increase in lambda m or conductivity. Okay. This is in the case of weak electrolytes like acetic acid. Okay. So, lambda m increases steeply on dilution, that is especially at lower concentration. Now, at infinite dilution, what happens? At infinite dilution, C approaches 0. Okay, lambda m will be equal to lambda 0 of m. So, alpha will be 1. And lambda is equal to 1. And electrolyte dissociates completely. But conductivity of the solution cannot be measured accurately. We can see that here from the graph, conductivity at lower concentration cannot be measured accurately. Cannot be measured accurately. Okay. So, we are using lambda 0 of m of weak electrolyte is obtained by using Kohlrausch's law. Lambda 0 of m in the case of weak electrolytes is obtained using Kohlrausch's law. Kohlrausch's law. Okay.